Hi, my name is Mike Sadler and I am with Denso Aftermarket. Air conditioning is now a commonplace feature in the country's vehicles, which, as well as the increased levels of comfort it provides, a correctly functioning system brings health benefits to all the vehicle's occupants in terms of their protection from airborne particles such as pollen and pollution, a particularly useful factor in the light of the coronavirus pandemic. Both of these factors mean that workshops not only need to be able to tackle AC service and repair with confidence, but also understand some of the problems that can arise if replacement AC component installation procedures are not followed. That's why we're here with Hayley Pells at Avia Sports Cars to bring the first of our Denso in the Workshop webinars, which over the course of the series will address a number of subjects, including spark plugs, rotating electrics and diesel. It begins with a focus on AC. The first, today's webinar concerning oil contamination, which is part of Denso's 7-step guide to basic AC service. And the second, common faults following compressor replacement.
Hi Mike, so before starting any AC service work, is there any best practice advice that Denso recommends?
Absolutely. An important starting point to any work on the AC system is to assess the condition of the oil refrigerant mixture, particularly if you don't know the service history of the vehicle or have not previously serviced or repaired the AC system of one you know. The condition of the oil will help when diagnosing many other faults, but it also establishes a baseline from which to work.
So how do we start?
Okay Hayley, this is the essential piece of equipment when carrying out an analysis of the refrigerant and oil mixture. It's the sight glass. The sight glass allows you to extract the mixture into the sight glass, so then you can assess the condition of the refrigerant and oil mix. The beauty of that is, one, if it's contaminated, you're not taking the contaminant through the refill machine. So you have the sight glass, high pressure line, low pressure line. They can't be confused when fitting because the quick release adapters are of differing sizes.
So how do we go about using this?
Prior to fitting the sight glass to the system, all the air must be purged out using a vacuum pump. Once the air has been purged, connect the high pressure adapter and the low pressure adapter. The unit is now ready for sampling. Okay Hayley, make sure the high pressure valve is in the closed position. Then open the high pressure valve on the system itself. You can now start the engine and ensure the air conditioning is switched on. Slowly open the high pressure valve on the sight glass and allow the mixture to fill the glass to half full and then close the valve. This process allows the oil refrigerant mixture within the AC system to be diverted into the sight glass to enable you to see its consistency and condition, which will help you to know how you have to progress. To empty the sight glass and its hoses, first close the red coupler at the high pressure service port, but before you open the blue coupler at the low pressure service port, make sure that the low pressure valve on the sight glass is closed. Open the high pressure valve on the sight glass, otherwise the refrigerant and oil mix inside the red hose will not be returned to the AC system. Then slowly open the low pressure valve on the sight glass, which will allow the AC compressor to draw out the oil refrigerant mixture from the sight glass and its hoses. Okay Hayley, we've now established the condition of the mixture in the system of this vehicle, so what have we found?
The mixture was transparent and clear, but with a greenish yellow tint. So what does that mean?
This is a good result. As we can see, the R134A refrigerant and Denso ND8 oil are perfectly mixed, and the yellow-greenish mix indicates UV dye is present. But its discovery has implications that have to be explained.
Why? What's the problem?
UV dye would have been previously added to the mixture to show if there were any leaks from the system when looked at with the ultraviolet light. However, dye should only be ever added to the mixture once. It must be SAE approved and limited to 3 to 5 cc for systems up to 1,000 grams of refrigerant. Higher levels of dye will reduce the lubrication properties of the oil, which can lead to problems with other components within the AC system, including compressor failure. Another thing to be careful of is the fact that some AC refilling machines are set to add UV dye automatically, which is why the sight glass test that we are discussing here is so important to begin with. Also, it's important to know that some car manufacturers such as BMW and Toyota do not allow the use of UV dye during the vehicle's warranty period, so always use it with discretion. The ideal oil refrigerant mix, therefore, is clear without dye.
So we've seen that the mixture in this vehicle is good, but what might we have seen if things weren't so positive?
Yes, it's now time to take a look at the bad.
Okay, so this mixture is light grey. So what does that indicate?
Although the R134A refrigerant and Denso ND8 oil combination is right, there is too much moisture in the mix, which is bad. And as well as the system having to be flushed, it will also require the receiver dryer and filter element to be replaced.
Although the mixture here is clear, there are two different layers.
This means the oil and refrigerant are not mixed. This is because, despite what some suppliers may suggest, universal PAO oil is not compatible with 134A refrigerant, as the two do not mix properly, so they must not be used together.
Now this one has a light and milky appearance, but with layers.
This is because two types of oil have been used in the system. As with the previous example, R134A and universal PAO cannot mix, and neither does Denso ND8 oil and universal PAO. So although the refrigerant and the Denso ND8 oil are mixed, there are still two different layers with the PAO oil separated at the top, which is obviously bad.
This one's similar, but cloudy in appearance, and again with layers.
This is the same problem as the previous example with refrigerant, with Denso ND8 oil and the universal PAO, but with the additional problem of too much moisture. This is even worse because, as well as not being able to mix, it creates paraffin particles which can clog the control valve, for example, and destroy the compressor.
Now this clearly has dirt or debris in the mixture, so what's that from?
This example demonstrates a different problem because although the 134A refrigerant with Denso ND8 oil is mixed, there are, as you've said, particles in the mix. These are likely to be rubber particles from the discharge hose, which takes hot gases and, over time, depending on the quality of the rubber hoses, the hose material deteriorates and breaks down, causing it to enter the system and contaminate the mixture.
What do you make of this one, Mike?
This is particularly likely to occur if you're working on electric vehicles, hybrids, and vehicles with electric scroll compressors, which should use Denso ND11 oil. The appearance is milky, and although apparently mixed, it's likely to be contaminated with ND8. These two oils should not be used together because although the refrigerant mixes with both, the oils themselves cannot mix, which we can see in this close-up image.
Okay, we've seen several examples, but are there any others?
There are a couple more that are worth highlighting. One relatively common, the other fortunately less so. If the oil is black, it indicates that there was a previous problem that meant the system had to be flushed to remove residue before it was refilled. However, it was clearly not flushed properly, so some dirty burnt oil remained behind to contaminate the new mixture, which means it will need to be flushed again, but properly. Finally, if you see residue like this around the joints or connections in the AC system, be wary because it indicates that leak stop has been used in the system. However, leak stop should never be used in an AC system because although without the presence of air or moisture, it is a liquid. When it's exposed to either, it becomes a solid. So if evidence of its use is found, do not connect it to the AC filling machine because, as well as it being impossible to remove from the vehicle's AC system, which will need to be replaced, it will contaminate the AC refilling machine and ruin its internals.
Wow, that's a really useful tip. So now that we have established the condition of the mixture in the system, I guess we're able to make correct decisions when it comes to the next course of action.
That's right. However, if the mixture did need to be replaced and the system flushed, two things need to be borne in mind. First, the quantity of oil to be put back in the AC system, which must precisely match the vehicle manufacturer's specification, and second, that it's likely that other components in the system will also need to be replaced, and the correct installation procedure has to be followed to prevent the subsequent failure of these parts. One of the components that might need to be replaced is the compressor, which is why discussing the most common compressor failures is the subject of another Denso in the Workshop webinar. In the meantime, however, you can sign up to be notified of future webinars and see more on demand, including my colleague Richard Groot's 7-step guide to basic AC service. In addition, more of Denso's IMI accredited training can be accessed through the online e-learning education program, and while you are there, why not sign up for the League of True Mechanics competition, where you can be in with a chance of winning a set of Bose wireless headphones, a Team Toyota Gazoo racing jacket or Team Gilet, among other fantastic prizes.